Hello everyone. We are here to present our project titled IPSec Overview Simulation. Our team members are Preetham M. Rao, Yashas, Nikhil M. Padmashali and Prithvi Shelnai. Okay, let us first understand why data security is important. Data travels across networks in the form of packets from sender to receiver. During this process, the data passes through multiple intermediate nodes, which makes it vulnerable. If the data is not protected, attackers can intercept it, read it, or even modify it. If the data is not protected, attackers can intercept it, read it, or even modify it. Therefore, we need a reliable mechanism to ensure that data remains private and secure during transmission.
To solve this problem, we use IPSec, which stands for Internet Protocol Security. IPSec is a suite of protocols that operates at the network layer and secures IP communication by encrypting and authenticating each packet. It provides end-to-end security by creating a secure tunnel between two systems. IPSec offers several features like confidentiality. Data is encrypted using algorithms like AES. Integrity ensures data is not modified. Authentications verifies identity of senders. Anti-replay prevents reuse of captured packet. IPSec mainly uses two core components like IKE and ESP. IKE used for key exchange, ESP used for encryption and data protection.
Now coming to our project objective, our goal is to build a browser-based simulation that demonstrates how IPSec secures communication from sender to receiver. We have implemented this using HTML, CSS and JavaScript. The simulation includes encryption process, secure transmission, decryption, packet animation, progress bar and attacker view. Now let us move on to the working demonstration. Step 1. Input message. Here the sender enters a message that needs to be transmitted securely. When we click on encrypt and send, the IPSec process begins. First, the system performs key exchange using IKE. This step establishes a secure connection and shares encryption keys between sender and receiver. Next, the message is encrypted using ESP. The original readable message is converted into ciphertext, which cannot be understood by unauthorized users. Now, the encrypted packet is transmitted through a secure tunnel. This is visualized using the moving packet animation.
Now let us understand the packet structure in IPSec. The packet consists of IP header, ESP header, encrypted payload, and ESP trailer. The actual message is inside encrypted payload, which cannot be read by attackers. Even if an attacker interprets the packet, they only see encrypted data, which appears as random characters. Now at the receiver side, the message is decrypted using shared key. As we can see, the original message is restored successfully. Now we will take a brief look at implementation. This is our HTML file where we designed our layout. This is the CSS file used for styling and animations. And here is the JavaScript file where we implemented the logic for encryption, progress bar and packet movement. Now let us take a brief look at the JavaScript implementation and which is behind our simulation. Here we use JavaScript to control the entire IPSec process flow. First we take input message from sender using the input field. Then during encryption, we convert the message into encoded format. This simulates AES encryption used in IPSec. Next we update the progress bar step by step to represent key exchange, encryption, transmission and receiving. We also use time delays using functions like setTimeout function to simulate real-time communication between sender and receiver. The packet animation is handled by dynamically changing position of the packet element across the screen. Additionally, we display the encrypted message in the attacker section to show the intercepted data is unreadable. Finally, during decryption, we convert the encoded data back to the original message and display it at the receiver side. So overall, JavaScript is used to simulate the IPSec workflow in an interactive and visual manner. From the results, we can see that before encryption, data is readable. After the encryption, it becomes unreadable. After decryption, the original message is restored. This demonstrates that IPSec successfully protects data during transmission. In conclusion, IPSec provides strong and reliable approach to secure communication and is widely used in VPNs and enterprise networks. Thank you.